Live now. Sir, you may proceed.
Okay. Greetings to uh, all the distinguished participants here, and all the esteemed speakers and panelists on the stage to this session number 8 of the Tech Deep Dive Conference of TSDSI. And the today's topic is Spectrum for Next Generation Services, which is for a period. The duration is 2 hours and 15 minutes. You would have seen on the agenda. I am A.K. Mittal, associated with TSDSI as advisor, networks and systems and technologies, and I am the convener of this session. I am Before I introduce the session, I will just like to bring to your notice of every participant here some important hygiene instructions for proper conduct of the session and proper participation and dissemination of information which is being shared here. One is that all of you, everybody has been kept on mute by default for audio and video. And for that, if anybody has question, the questions can be typed in the Q&A tab, which will be picked up at an appropriate time by the session co-chair and the moderators, and they will be put for answers to the relevant speaker. And please, there is also a chat box available where the participants can chat among themselves. And our request is kindly post the questions only in the question box so that they are easy to identify. In the chat box, it may be difficult to identify sometimes if there are too many chats. So kindly post your questions in the Q&A and wait for the moderator or the co-chair to take up the questions as the case may be. And one issue which normally sometimes you may face is the audio or video problem. Then one of the solutions could be that you can switch from HD video to LD video, which is right at the right bottom corner of your screen, HD, and you can switch to LD. It can probably remove the audio problem. And for seeing the full screen, so there is a full screen tab at the right top corner with 4 arrows. If you can, if you click that, you will see the full screen presentation. And third is that next is that the this conference is this session is being recorded, and its recording will be made available publicly in due course. And this hygiene instructions is being also put in the chat box for reference by the participant at any time if they have any difficulty, so they can refer to this. Next slide, please. Yeah. So now I can briefly introduce the session. As the name suggests, we are talking about spectrum, and all we know is today the telecom is predominantly governed by the wireless services. So spectrum, the importance of spectrum cannot be overemphasized. But whatever spectrum we see today being available for 4G services, 5G services, and even earlier, that has been a result of lots of studies, cooperation among the administrations and various stakeholders, harmonization of a spectrum, and issue of necessary regulations so that all users are able to properly use the allotted spectrum. They don't interfere with each other and services are provided smoothly. So now, after the 5G deployment has started and the world is now looking at the next generation of technologies, which naturally people have named as 6G in advance. So for 6G also, because every generation has enhanced level of services and capabilities, so everybody expects that additional spectrums will be required for 6G or the next generation of services. And similar issues which have been addressed in the earlier generations will be required to be addressed right now as far as the spectrum is concerned. So in this session, our focus is on spectrum requirements for the next generation technologies and services, including non-terrestrial networks. So this is a new component which you will see that apart from terrestrial network which we are used to, satellite component of the mobile or mobility is going to play a larger role in the coming days, even in the later 5G era. And 6G, we will see, we are expected to see a large scale integration of the satellite services into the terrestrial services for a kind of so-called, if I can use the word seamless service, that kind of expectation is there. People are working in that direction. And when we talk about spectrum, then regulatory aspects, of spectrum cannot be forgotten. There are so much in regulation of spectrum for proper use by all the users. And this also requires harmonization, because same spectrum, when it is used, how to harmonize so that wider bandwidths are available, coexistence is possible. So these three are the main topics, but this is not all. We have here a lineup of very esteemed and knowledgeable and experienced speakers. So they will share their vast knowledge space. And this is the session schedule in brief. This is available in the brochure. You can go into details. So there are 2 keynotes and a panel discussion. And after every keynote, there will be a Q&A for audience, which will be controlled by the co-chairs and the moderator. And in the end also, audience will get a chance uh, to address questions to the panelists or speakers at the end. So this is the session is. Now let me introduce the co-chairs of this session. The session is co-chaired by Professor Radhakrishna Ganti from IIT Madras and Ms. Neha Satak from Astrome Technologies. I can briefly tell you about these esteemed speakers. Professor Radhakrishna Ganti is an associate professor at Indian Institute of Technology, Madras. He received his BTech and MTech in electrical engineering from IIT Madras and Masters in Applied Mathematics and PhD in electrical engineering from University of Notre Dame in 2009. He received the 2014 IEEE Stephen O. Rice Prize and 2014 IEEE Leonard G. Abraham Prize and the 2015 IEEE Communication Society Young Author Best Paper Award. He was also awarded the 2016-17 Institute Research and Development Award IRDA by IIT Madras. In 2019, he was awarded TSDSI Fellow for Technical Excellence in Externalization Activities and Contribution to LMLC use cases in ITU. Now next I introduce you to the other co-chair, Ms. Neha. Neha is the co-founder and CEO of Astrome, a millimeter wave deep technology company building products for rural broadband and 5G. She holds a PhD from Texas A&M University and a master's from Indian Institute of Science in Aerospace Engineering. She was awarded the prestigious Amelia Earhart Fellowship by Zonta Foundation during her PhD. And then in 2020, she received the Unreasonable Fellowship, a global community of select growth stage entrepreneurs, institutions, and investors to profitably solve pressing global problems. She is also a WEQ Fellow, an award jointly given by Anita B. Org, USISTEF, and Government of India. In 2019, she was selected for ITU's Equals program. She is also a Amelia Earhart Fellow 2012 and Karman Fellow in 2021. So with this introduction of the co-chairs, now I hand over for further conduct of the session to the co-chairs and I request Professor Radhakrishna Ganti to take the session forward. Thank you very much.
Thank you, Mittal sir, for the warm introduction. And I would like to welcome all of you to this workshop on Spectrum for Next Generation Services. It's a pleasure to be here and interact with all of you. We have a great line of speakers and panelists lined up. I want to first introduce Dr. Laura Roberti. Dr. Laura Roberti is a director for Spectrum and Market Access in Telesat. She's responsible for regulatory licenses and authorization, including the new Telesat Lightspeed system, and she regularly participates in ITUR and ITUD work. She holds a PhD in electronic engineering from Polytechnic of Turin, Italy, and has many years of work experience in both industry and academic work. Her experience covers both satellite and terrestrial communication, which is what this session is about, and also in spectrum management and engineering. She's the author of several research papers in the area of radio propagation. Prior to Telesat, she has worked for Immersat, British Telecom, NASA, and the Polytechnic of Turin. We welcome you, Dr. Laura Roberti. The floor is yours.
Thank you very much for this introduction. Good afternoon, everybody, Mr. Chair, the Vice Chair, and all the esteemed speakers and all the participants, of course. I'm very honored and grateful to be given this opportunity to present a few slides on the issue of spectrum for novel non-geostationary systems in Ka band. So if we may go to the next slide, please. Thank you very much. So India, I would like to start by mentioning the recent developments in India from a regulatory perspective, especially as far as satellite services are concerned, as there is a lot going on at the moment. I would like to start by mentioning, for instance, the consultations that have been issued by TRAI, one of which was on the licensing framework in relation to establishing gateways in India. In these consultations, there was a reference to the possibility or the need for the gateway Earth station to have a separate license for the service provision one. And also there was a mention of the need for a possible revision of licensing fees. Furthermore, also the important issue of spectrum allocation for satellite services was started to be addressed in this consultation. October this year has been a super busy month in India from, again, a regulatory perspective. The revised National Frequency Allocation Plan has been published. And from the satellite perspective, and especially in relation to Ka band, there are some important changes. In one of the footnotes, the frequency band that's been discussed for a long time, 27.5 to 28.5, has been identified for IMT. However, via an additional subnote, the same frequency band is still allowed for potential shared use by IMT, in other words, terrestrial 5G, and satellite services subject to feasibility. So even if this is not an ideal outcome from the satellite industry, at least the door is still open for possible satellite operation in this band. And I'll emphasize a bit later on how important this band is. Furthermore, via an additional footnote 17, the frequency bands, the Ka band, the frequency bands that are identified at Indian domestic level for use by Earth Station in Motion. Earth Station in Motion are satellite terminals that can be installed on aircraft, ships, or land vehicles, have been extended of an additional 1 gigahertz, which I think, once again, is a very good initiative. I personally don't understand why the lower bound of the space to Earth direction is 18.7 rather than 17.7, but this may be the topic of an offline discussion. Furthermore, a booklet has been issued with satellite communication reforms, always in October, and again, some very good initiatives, such as the removal of the Network Operation and Control Center fees, the opening and the availability of an online portal for license applications, which is a fantastic initiative. And also things are moving towards really enabling the operation of Earth Station in Motion that I've already mentioned. Finally, always in October, a consultation has been issued on the new draft telecommunication bill, which is intended to replace some older regulations. And again, there are very important aspects concerning satellite operations, such as the issue of spectrum allocation, possible spectrum refarming, the introduction of regulatory sandbox to facilitate demo testing also for satellites, which is very welcome by the satellite industry. This is also in the context of the ongoing revision of the space policy that, again, in relation to the consultation that was issued, I believe, 1 year ago, is really in the spirit of a forward-thinking attitude towards the development of the space industry and an increased involvement of the space private sector. So all this to say that there is a lot going on in the right direction, and the texts that have been published are really clear, straightforward texts that really show a general trend towards streamlining and simplification of the regulatory process. If we may go to the next slide, please. So since this presentation is about spectrum, I'll go just briefly a bit more into the specifics. The spectrum that is planned to be used for the Telesat LEO non-geostationary system that is being developed, the Telesat Lightspeed, is shown in this slide. So indicatively from 17.8 to 20.2, 27.5 to 30 gigahertz. And this, so more or less a bit more than 4 gigahertz of spectrum overall. And the Telesat is not the only non-geostationary satellite operators planning to use this spectrum. In fact, other non-geostationary satellite operators are planning to do the same, like Telesat, to use the spectrum both for the user terminals and the so-called landing station or gateways, while others are still planning to use the spectrum, but only for the gateways. Needless to say that there are many geostationary systems that are already operational or are planned, that are also planning to use this spectrum. Next slide, please. I would like to spend a few words. Sorry, these slides are a bit too many words, but there are several points that I believe are important. So when it comes to non-geostationary gateways, the situation is a bit different from the geostationary ones, in the sense that the gateway is not provided by the single antenna, but rather a non-geostationary gateway that is also called landing station or antenna farm is essentially a site that comprises multiple identical full motion antennas. Full motion because, of course, the antennas need to move to track the movement of the satellite. In general, as it's the custom elsewhere, the gateway license is normally separate from the service provision license. And why? For a number of reasons. So first of all, a gateway license normally does not confer any right for provision of services to the customer. So it makes sense for it to be separate. Also, this separation guarantees a level playing field among the service providers, because there is no need for each service provider to provide a gateway, which in turn also allows for an optimization of the ground infrastructure deployment, because as a satellite operator, it will only be necessary to deploy a number of gateways that are just necessary for the optimal operation of the systems. They're not imposed by additional regulatory requirements. So in general, it is possible for either the satellite operator or the teleport operator or a service provider to acquire this license. So in other words, there is some flexibility in that respect. From the licensing point of view, the fee point of view, while each antenna is tracking a different satellite at any one time, the overall range of pointing angles, transmit powers, and frequency is essentially within the same envelope. So in other words, from an operational perspective, this group of antenna behave from an interference perspective, a spectrum use perspective, as a single one. As such, we are of the view that rather than individual fees and licenses for each single antenna, a single license for the site is an appropriate and a reasonable way forward. And this is a principle that has already been adopted by a number of countries in which this type of deployment is already taking place. Gateways, furthermore, gateways are normally considered as infrastructure. Therefore, a fee that is based on a revenue-related formula is not necessarily appropriate for this type of licenses. What is normally done is either a flat fee or a spectrum related fee. In other words, a fee that is proportional to the spectrum used. Considering that, again, in these cases, 4 gigahertz are used, the multiplying factor needs to be a reasonable one in order to make the business case viable. Two more points I would like to make. From the point of view of the technical standards, normally there are no standards applicable to gateways. And why? Because each gateway is very much it's been designed specifically for a specific system. So it's a very different situation from the user terminals that are mass produced. So in that respect, it could make sense to reconsider the possible requirement for compliance with the technical standard in relation at least to non-geostationary gateway or stations. Very final point, when it comes to the requirement to deploy multiple non-GSO gateways from different satellite operators in the same countries, we are of the view that there is no need for a fixed predefined distance among such gateways, because this is part of the satellite system coordination that is already taking place between satellite operators. And again, there is no evidence that large distances are required. It really very much all depends on the specific technical conditions of the systems and the overall arrangement in the coordination process that also takes into account the priority of the filing. Next slide, please. Thank you. So I would like to touch upon the very important issue that is again very relevant in India at the moment, as I understand it. That is the issue of spectrum assignment for satellite use. This is something that has already been mentioned a few times by the satellite industry, but allow me to repeat it one more time. As Telesat, as an industry in general, we are of the view that spectrum, especially when it comes to microwave spectrum, so C-band, Ku and Ka band, should be assigned based on an administrative process when it comes to satellite use. And this is the standard procedure elsewhere. And why is that the case? Why is normally spectrum assigned administratively for this purpose? Because microwave spectrum can be shared among multiple satellite operators thanks to the directivity of the antenna. So in other words, 2, 5, 10, 20 satellite antennas can sit in exactly the same location, use exactly the same spectrum, and point at different satellites, in this case, for instance, on the geostationary arc. This is not the case for terrestrial mobile operator, because again, for instance, in our mobile phones, the antenna is omnidirectional antenna. There is no directivity whatsoever. So it's a very different situation between the two cases. So in other words, to conclude, an auction for satellite microwave spectrum, what would be the consequence, the possible consequences? First of all, an artificial limitation in the number of satellite operators allowed to share the spectrum and their exclusion from the market. And this could potentially lead, of course, to possible unjustifiable monopolistic situation. And also another alternative is to partition the spectrum. And this again, why partition the spectrum if all satellite operators can use it at the same time? So from our point of view, this again would be an inefficient and unnecessary partitioning of the spectrum that we all recognize as a very scarce and precious resource. If we may go to the next slide, please. So one of the questions that is normally asked is how can all these systems coexist, in particularly these non-geostationary systems. I'm not personally a coordination expert, but I just wish to give a very high-level outline of what the situation is in relation to Ka band. So in terms of protection and coexistence with geostationary systems, in most of the Ka band, there are some limits called EPFT limits. I don't want to go into the details that non-geostationary systems have to respect, to comply with, to protect the geostationary networks. And this allows protection and no coordination is required in this band. In the rest of the band, coordination needs to take place under the relevant provisions of the ITU radio regulations. When it comes to non-geostationary systems, this again, coexistence can be ensured by complying with the coordination provision in the radio regulation, taking into account the priority of the filing. And the analysis is being carried out by the different non-gestationary operators in bilateral coordination discussions. And for instance, Telesat recently reached a coordination agreement with Amazon Kuiper, and I think it's important to highlight this, as both of these systems are planning to use Ka band both for the gateway and the user terminals. Next slide, please. I would just like to conclude without going into the details, mentioning two agenda items. But why am I doing this? So this is about spectrum, Ka band spectrum, and I mentioned before that is important to satellites. In fact, there were agenda items at the WRC 15 in relation to Ka band use by satellite, WRC 19, and now two more for WRC 23. One is agenda item 116, that is in relation to the possible operation of Earth station in motion with the non-geostationary systems in Ka band. And we believe that a successful outcome of this agenda is important, not only to allow the operation of EASIM, that is on our direct interest, but also to guarantee, to make available a much required harmonized international framework that will also ensure the protection of existing systems. Because for the time being, there are some domestic rules, there are some regional rules, like for instance in Europe, but there are no international sharing conditions rules that are clear for every administration and also for all satellite operators. Next slide, please. In general, I would just like to highlight one point. Non-geostationary EASIM and geostationary EASIM are virtually identical from an operational and technical standpoint. In fact, many manufacturers now are producing terminals that can operate with other systems, GSO or non-GSO. Therefore, there is really no technical or operational reason why the regulatory framework for non-geostationary EASIM should be different or more restrictive than for geostationary ones. So once again, we support the adoption of an harmonized regulatory framework for non-geostationary EASIM along the same lines of the one for geostationary EASIM. And I would also like to emphasize that stricter and unjustified regulatory conditions for non-geostationary EASIM would also potentially lead to a regulatory discrimination of non-geostationary EASIM that, of course, have an impact from a commercial perspective, leading to a possible disadvantage. Next slide, please. The second agenda item that I would like to briefly mention is agenda item 117, and this is about allowing intersatellite links in Ku, but mostly I would say in Ka band. And why this is needed? Why has this been raised as an agenda item? This is a requirement that came mainly from the scientific non-geostationary satellite community in order to allow a user space station to download the data to the ground, to a ground station, also when the user space station does not see, when a ground station is not visible from the user satellite station, like for instance on the oceans, or again, in any case where a ground station is not in the field of view. This data relay would in this case happen via a satellite provider space station that can be either a non-geostationary or a geostationary satellite. So this is where the requirement stems from. If we can go to the next slide, please. I'm not going into the details, but I have to admit that this is a very complex agenda item because there are a number of combinations. Either operation under the existing fixed satellite service allocation or new allocation under intersatellite service, different concepts of operation, different methods being proposed to protect existing systems. All this to say that there is a rather complex, I have to say, CPM text that takes into account all these various combinations. all I want to conclude with is that we hope for support towards an introduction of these possible services. In other words, satellite-to-satellite transmissions, of course, ensuring the same level of protection to incumbent system that is currently provided in the radio regulations. And with this, I thank you all very, very much for your attention, and thank you.
Thank you, Dr. Laura. I'll now open the floor to the audience for any question and answers. There is one from Mr. Puneet. I'll just read it out for. Typically, we have observed that the GSO operators in the K-band are very worried about potential interference. If the source of interference is terrestrial, even in the case of beam pointing below horizon is seen as grave. The grave risk to the voice operation.
Thank you for this question. In the case of Ka band, the frequency range in which interference could occur to satellite systems would be in the Earth to space direction. And in this case, interference could be caused by, how can I say, large aggregate interference from large terrestrial deployment up to the satellite. But again, this also depends for transmission below the horizon. But at least in my view, again, it also depends on the specifics of the sharing studies. But this risk of interference should be reasonably contained. However, if again the so-called 28 gigahertz band would be intensively used by IMT terrestrial deployments on a large scale, I would imagine that yes, that could potentially lead to interference to the receiving space station.
Thanks, Laura. There's one more question. Okay, yeah. It says if the source of interference is NGSO, non-geostationary orbit, the risk is even higher. There's no clutter loss. Beam pointing below horizon can also potentially be directed in both sides of another GSO.
In this case, I would say, if I apologies in advance if I don't interpret the question correctly, but as I try to explain, there are ways to protect the GSO from non-GSO, and in particular, there is no possibility of non-GSO terminal pointing directly to GSO because there are specific geostationary arc avoidance that is actually being implemented in non-geostationary systems.
Thank you.
I hope I've replied to the question.
So any other questions?
No more questions, sir.
So I'm just curious, in one of the slides, when you're talking, you mentioned that while satellite spectrum should be an administrative, licensing of satellite spectrum should be an administrative issue, unlike auctioning for the terrestrial. But given this non-terrestrial networks are happening where satellites are going to cover 5G, they're going to do equivalent of 5G, shouldn't the satellite spectrum also be auctioned?
As I try to explain, at least in my view, allocation of spectrum needs to optimize the use of spectrum. And in the case, again, of satellite spectrum in a microwave frequency bands, for instance, for provision to VSATs or Earth station motions and so on, all this spectrum can be shared in the same location by satellite operators. And therefore, again, from the optimization of satellite use, a spectrum auction would imply limitations in the number of satellite operators that are allowed to use the spectrum that are not justified by physics. It would be an artificial constraint that I've not seen in any other country.
Okay, thanks, Laura. I mean, we'll get to this point when we do the panel discussion again. Thank you.
Thank you.
No more questions, sir.
Thanks for
Yeah.
the wonderful talk. I mean, it was very interesting to understand how these NGSOs are now coming into picture. We're looking forward to hearing more from you later in the panel discussion. Thank you again.
It's me who thanks you very much. Thank you.
Professor Ganti, there is one more question for Laura. Can we?
I think there is Puneet. I think we are running out of time. I think Puneet, maybe you can directly message Laura. I will send that thing to Laura. Yeah. I'll now
Directly in the comment box, you can respond that question. Thank you.
Now I'll ask I ask Neha to take over from here. Thank you.
Thank you so much, Professor Ganti. So it is my pleasure to introduce the next keynote speaker, Ms. Revati. She is very uniquely qualified to address us today because of her long experience of 26 years working on matters related to spectrum, including spectrum monitoring, spectrum auction, national regulations, Indian regulations, satellite coordination and international regulations in various capacity during her tenure at WPC and WMO. She has represented India as a techno-regulatory expert at the International Court of Justice, also The Hague. And recently, she has been elected as a member of Radio Regulation Board for ITU for the period of 2023 to 2026. She graduated in electronics and communication engineering from Jawaharlal Nehru Technological University, and then did her postgraduate studies in public policy management from the Management Development Institute in Delhi. So please help me welcome Ms. Revati for her keynote speech. Thank you so much. Ms. Revati.
Thank you, Neha. I think I'm audible. I'm audible. Is my audible?
Yes, you're audible, ma'am. Yes.
First, let me say my apologies for postponing my keynote address. There was a sudden requirement for me to go to Minister's office. I just returned. I think I'm well in time. And very good afternoon, distinguished panelists, keynote speakers, and delegates. The topic given to me is Spectrum for Next Generation Services. And I have added opportunities and challenges. Let us go through it from the regulator perspective. The first slide. Okay. Probably what I'll be addressing is mostly from the spectrum manager point of view. Sometimes my view may be limited because we interact with industry, we interact with standards organizations, we interact with ITU and all. But practically, probably there may be some gaps. The other panelists can fill the gaps. When we are talking about the spectrum opportunities for next generation services, first I thought, let us find out what are these next generation services. And I tried to list them. And some of them I listed here. The first one I started with 6G services. Of course, the next IMT services. The next is LEO-MEO. LEO-MEO satellite based, FSS and MSS services, fixed satellite services and mobile satellite services. Apart from that, high throughput satellites, which are mostly operational in the GS. Then we have a V2X and ITS, Intelligent Transport System. Vehicle to anything. This is again a new services. They also need lot of spectrum. Encompasses so many things. Now everybody is talking about smart cities, smart infrastructure, smart people, and reduce the carbon footprint. So where this V2X and ITS is very essential. This is one of the new services, next generation services. Then comes IoT, M2M, Internet of Things and machine-to-machine communications, both terrestrial And narrowband satellite based, they also need some spectrum. Then already one service, it is already in the doorstep of GOT. We are still working on the regulations for that. That is Industry 4.0. That is a private 5G. The spectrum requirement for it and what is the allocation methodology. Then another interesting thing, I missed my colleague Lara's presentation. It must be very interesting. She talks a lot about NGSO, intersatellite links and GSOs, eSIMs and all. So another important thing is intersatellite links. Intersatellite links also very essential because of this large constellation of LEO satellites. And you need large bandwidth for this. So I try to list out few services. There are still some of the next generation services. I listed these services because currently we are focusing more on this. And this is the current topic. We have to really issues, how to give the these services. That's why I try to capture this. And some of these services are already deployed in some countries, and some of them are under development. And in India, we are at different stages of these services. Next slide, please. Having said that, so I try to identify some services now, next generation services. Now, what is the spectrum requirement for these services? Whether the spectrum requirement is different for these services in different frequency bands, or every one service requires the same spectrum. What is the scenario? So I try to draw your attention to most important, that is IMT band. Is an example. Similarly, we can talk about all these services. And when we take about this IMT band, here I have not added 24 gigahertz millimeter wave band because we have almost done a lot of work on that and we have auctioned also. We are quite clear what we are going to do, at least in this 24 gigahertz band. Come to higher frequency bands, we don't know, we are working on them. I try to put those bands, 37 to 43.5, I just leave. That is one band. Another is 47.2 to 48.2 gigahertz. The next is 66 to 71 gigahertz. We all know very well, these future IMT services, they need a large amount of contiguous blocks of spectrum. No denial, everyone agrees for it. For this ultra low latency and very high bit rate. This is one end of it. Next side you see, that is a space-based services. I said they are also next generation services. They also need a spectrum, and unfortunately or fortunately, they also need the same spectrum, same band. They are high throughput, NGSO constellation. Similarly, you go to the other frequency bands. I was talking about Industry 4.0. That is a captive 5G, private 5G. There, they also need some portion of the IMT bands. TSPs also wants IMT band. So how to do this segmentation? How to accommodate different services, different users without causing interference, without having problem, and providing a sustainable regulatory framework for them, for the growth, future growth. That is a big challenge. Next slide, please. So that is one example I have taken. Then we have so many like that, V2X. We have intersatellite links. Even within the satellite, already we have GSO FSS. Now we are putting NGSO FSS into it. And we are bringing eSIMs into it. We are bringing intersatellite links into it. How to coexist all these? If cannot coexist, how to share the spectrum bands? Whether band apportionment or dynamic sharing or coexistence with the keep of distances. What is the methodology we have to follow? There is no single method. How we are going to do this apportionment of the bands among different services? Is a sharing, band segmentation, or dynamic sharing? This is a big question mark. And I expect probably at the end of the day, some answers to these questions from our expert panel discussions. Next slide, please. There is what we see as a spectrum manager, there is a paradigm shift. The same band is shared by different people. Is it new? No. We have been doing in India. We have been doing this process has been there across the world. Is it first time spectrum is shared by various services, especially two different commercial services? Here insistence, two different commercial services. No, we have been doing it. Then what is the challenge now? Why we are facing a lot of challenges now? Why? I try to summarize. I try to put what are the pointers we are having this difficulty. Small skull inter-service guard band. No fixed band segmentation. Now we cannot do that. Keep off distances. Legacy systems with wider front end. I'll come to this one by one. When we first started with this example, when we first started with, you can go back to the last slide only. We can come to this example. When we first started with the GSM in India, there is a band, some band we defined. Then there is a CDMA. We can say we were rich enough to leave 1 megahertz separation between GSM and CDMA. Then when we introduced in 2012 liberalized spectrum assignments, that means GSM and LTE will come in the same band. Again, that time we were little, we were rich enough to leave 0.2 megahertz guard band between these two technologies. As the demand increases, as efficiency, as the technology advances, we don't have any guard band left between any of these now. That means your stingments, that guard band requirement is being reduced. The same is case with the CDMA. So with the commercial services, we have evolved like that. Now you go to the service of, recently we have auctioned mid-band spectrum, that is 3.3 to 3.670 gigahertz. Though it is up to 3.670, we have put for auction up to 3.600. We started having lot of complaints from other commercial service, that is cable TV operator. That is nothing but TVRO. Please go to the next slide. The TVRO, we call TV receive only. Your cable TV operators. They started complaining. We are getting interference in this area. When the 5G people started testing, we are having interference here, we have interference there. The issue is, there is a sufficient guard band, but their front is so wide, they can receive any signal from 3.4 to 4.2. The earlier, there were no IMT operations up to 3.4. So no issues. People were coexisting nicely. So now the space is limited, the bandwidth is limited. We are trying to put more services. We are going for narrower filter characteristics and using the technology. But the other legacy systems, they have not changed their system. It is not cost effective. So they are receiving all unwanted signal also. And their filter is not tapered off. We have seen typical filter characteristics. It is wide open. They are supposed to receive satellite signal. It's very feeble. They are receiving, and they put a dish size of around 3.2 to 4.5 meter dia. The sensitivity is good. Instead of receiving his own satellite signal, they are receiving IMT signal because IMT is operating up to 3.6. We have these issues. We are doing on and off. We are doing experiments. We are trying to do some sort of changing the filters. That is one issue. These issues were there earlier, but now they are becoming more because we are trying to use a very efficiently leave only limited guard band. Then I'll come to another case, the same mid band. We have auctioned the spectrum. Of course, there were issues raised by DGCA and Airport Authority of India that aircraft altimeter is getting effect because of your mid band emissions of 3.6. And you know, aircraft altimeter frequency starts from 4.1 gigahertz. There is a separation of 500 megahertz. So far, I think they were comfortably operating because there are no other operations. Now IMT has come. They are telling you are causing interference. And see the remarkable difference here. First one is TVRO. That is a broadcasting service. It is not a safety service. You can afford to have some interference. Whereas altimeter, no, it is related to safety services. Your landing and takeoff. Not play with that. Now they come up and say, surrounding the airport area, you don't put the 5G towers, or you put low power or tilt antenna, you give a guard band of so much, so not, so and all. And no studies are being done in India, and it is difficult. What I am trying to say here is we have a challenges like this. We have a challenges. Earlier it was not like that. Okay, there is a big band, certain portion we used to give some service, another portion we used to give some service. Take the case of S band, 2.5 to 2.690. We carved out some spectrum and given to IMT, some spectrum it is with satellite. Now we are not able to do that. Even in the 3.4, we are trying to put the gateways and we are maintaining the keep of distance, and the remaining area we are using IMT services. These are some of the, this is the scenario, this is the paradigm shift, what I was telling. We have been doing, now there is a paradigm shift. So accordingly, our approaches also we have to change while assigning the spectrum or allocating the spectrum to different services. Can you please go to the next slide? So with this, I see a lot of opportunities as well. These are the challenges. Having said we have these challenges, but what are the opportunities? There is an opportunity for efficient utilization of the spectrum. Means I am able to, earlier I used to give a large swath of guard band unutilized. I was losing economic value of it. Now, no. I'm able to use very efficiently using the technology. So that precious natural resource, I'm able to utilize very efficiently. Then sharing between, if it's a satellite gateway terminal, you can share with IMT. And as on date, it is difficult to share with IMT and satellite user terminals because both are ubiquitous deployment. But if there are like even high throughput satellites, you have limited gateways. And these gateways are operating in the millimeter wave band. That is another advantage. The antennas are pointed and the coverage keep of distances comes to kilometers, like 2 kilometer, 3 kilometer. That's fair enough. You cordon off that area and use it for another ubiquitous service. That's a good thing. We started doing, we have to do that. Well, we started doing that even in the 24 gigahertz. And what we thought in when we were talking about that IMT higher frequency bands, 37 gigahertz and above, sharing between the IMT satellite services and radio astronomy and other services, we were also feeling this entire millimeter wave band, you don't need an entire service area. Now currently we are auctioning the spectrum for IMT on the service area basis, 22 service areas. I don't think probably we need this large swath of operator in the remote village or some suburban areas. There, you try to share that dynamically instead of dividing LSA, make it urban, semi-urban, rural. Divide the share between this terrestrial and satellite user terminals, not the gateway. Gateway is not at all issue. You can coexist with the limited. We have to come up with some idea so that we'll be efficiently utilizing the spectrum. At the same time, both the services need a large amount of spectrum. By band apportionment permanently, we are dividing the people of this up. So that's the another opportunity what I see, like possibility to assign lesser geographical unit than LSA. Like US and other, they try to do counties, they try to further divide into certain areas. So they try to put multiple services in that, like urban, semi-urban, rural, for each of the service areas. Can we go to the next slide, please? Then while doing these works, what we have seen in our WPC, there is another problem. What actually we perceived and we felt India-specific coexistence studies. People come and say, we asked this thing, you just tell what is the keep off distance you require, or how much spectrum you need, what you are projecting for the next 5 years to have a traffic of this much to cover so many people using a satellite or with a terrestrial. Unfortunately, the response is not that positive. With the concrete evidence, we need a lot of India-specific coexistence studies. For this with this technical parameters, approximately this much spectrum is required for this urban area, semi-urban, and with that, spectrum manager will be in a position to provide a roadmap, future roadmap, how we are going to do it. And without a roadmap, it is very difficult to come out, bring a new services, especially for satellite based, because they have to build the satellite. Unless you decide in advance, at least 10 years in advance, what is the band, whether you are permitting entire band or portion of the band or dynamic sharing, unless you give that indication, it is difficult for the industry to come and provide the services, to build the satellite, to launch the satellite for India. So my request is, and I feel strongly, sharing and coexistence is the order of the day, and learn and open to the idea of using the same spectrum for different services by using latest technological solutions, replace the old legacy system with spectrum efficient systems, and carry out India specific sharing and coexistence to find out the technical parameters for coexistence, like we were somehow able to do with this 3.4 NAVIC systems, because India was only having that. Somehow we are able to do that, carve out keep off distances, because the other countries, whatever ITR studies they have done for TVRO, not for CDMA receiving station. But we were able to get some information and technical details, and we could auction it. Similarly, for the other bands as well, we need that coexistence studies so that we can take an informed decision and informed technical decision. Then we can come up with a roadmap. I expect our eminent panelists will discuss further and come up with the solutions for the problems of spectrum manager. And I wish them all the best for their discussions ahead. Thank you. Thank you for giving me this opportunity.
Thank you so much, Ms. Revati, for the really enlightening talk. We'll just see if there are any questions. Team, could you please flash the questions on the screen? Great. So I think the first question is from Mr. Puneet Rathod. Ma'am, please.
Yeah. How to balance utilities for new services vis-a-vis poor implementation of the incumbents. This is a real problem. I can really see this. This is the real problem. We are trying to. The one way is when we ask them to change the filters, because we cannot leave so much of amount of spectrum as a god band. We badly need more spectrum in the midwave. Mid band, we need more spectrum. At the same time, we need broadcasting services as well. So we are trying to, DOT is trying to get to replace those filters, then finance. I think DOT is trying to fund through PLI scheme so that filter will be designed and replaced. Because you see around, how many? We calculate around 30,000 antenna front end have to be replaced for this TVRO. And they are very old systems. And you cannot replace them. I think you have to, they are embedded into that antenna. You have to replace that entire antenna. So we are trying to do, working on something to, so DOT can fund them so that will not make you want to cry, and they will use the narrow filter. That's a real problem, and different ministries involved. It is here. That is the issue. Oh, it's a good question. It's a good question. Who has raised this? Cognitive radio. It's a good question. Is
So I think Mr. Dr. Bhupendra Kumar, ma'am.
Acha, okay. Is cognitive radio implementation feasible in the dynamic spectrum sharing context using either an interview in underlay or overlay? Yeah. If yes, which bands are likely to address? Yeah, exactly. Regarding this cognitive radio, we have done, there was a committee constituted in the WPC to make use of this cognitive radio technology for utilization of various purposes, like in the delicensed band, in the licensed band as well. As you were telling, underlay and overlay interview, using as a white space, using as a delicensed band, or light licensing as a secondary use. For that, we need a software system which should be able to do it. Parallelly, the processing that, and cognitive radio committee also has they have given the report. I think it has been submitted. We actually wanted to use. We got some recommendations and representation from the industry using AFC technology to use certain frequencies for delicensing as well in the satellite bands. So all that we need tools, and devotee is parallelly processing that. And cognitive radio is a yes, we have to use that, we'll be utilizing. Any thoughts? WPC devotee to consider nationwide license and moving from LNA concept interest to more? No. Oh, it's a good question, Puneet, Mr. Puneet. Actually, what we were thinking of is not nationwide spectrum allocation. No, you further divide into units. This LSA wise itself is a big unit now, not nationwide. Not nationwide. Nationwide license, but spectrum is we are in the service area wise, and probably we have to find out a smaller unit as you go to higher frequency bands. Good. When we can have Wi-Fi 6 and 6E band? Good question. That only I think probably our minister only can answer, not me. I'm a too low a person to answer this question.
Great. Thank you, ma'am. One question from my side, if I may. But I think there is one more question probably from Professor Ganti. So maybe we'll take that first.
When will the spectrum be applicated for private networks? Yeah. Assigned for private networks. You're asking when will the spectrum be assigned to private networks?
Yes, for 5G private networks, ma'am.
That is what we call is CNPN, captive non-private networks.
Captive networks.
So it's now the process is set. For government has taken a decision to enable CNPN. They have given 4 provisions. One is TSP him or herself can provide a network slice of it. That is one option. Second option is CNPN. That is any private company holding a CNPN license can lease the spectrum from the telecom service provider. They're already enabled now. Somebody wanted to start that CNPN. He takes a CNPN license from the devotee and can lease the spectrum from TSP. We have enabled these provisions in the auction itself and the license conditions. Third option is that CNPN can directly obtain the spectrum from the devotee. So for this third option, there were different mechanisms in the devotee. The first is assess the demand requirement of this CNPN networks. For the demand assessment, one portal has been developed in the Saral Sanchar and opened it to public for 30 days, next extended for 20 days. You assess the demand, then you have to identify which are the frequency bands we can give the spectrum and the CNPN. That is another step. Parallelly, that is also going on. The third step is legal tenability of assigning the spectrum to CNPN people administratively. That also parallelly it has taken. We have sent to legal advisor. All these things culminates. We have to send this back to Troy. Then they will recommend us like what should be the block, how we have to assign and all. That time only, then I think probably we'll be able to decide whether we'll be able to assign administratively at option price or auction, or what is the method and all. Now it's all parallelly, and the four things are under process. I hope I have cleared your this.
Yes, ma'am. Thank you, ma'am. There's a lot of interest in this. That's why I was asking.
Yeah. Yes.
Great. Ma'am, just a follow-up question on that same question, like will spectrum like E-band or V-band be also allocated for the private networks for the backhaul, or is that another discussion which needs to start?
No. What is a backhaul? Why you need a backhaul? Private network.
So,
Why you need a
yeah,
backhaul?
yeah. So basically, in private networks, which are like industrial use cases where there is a large area to be covered, where you also need the backhaul to be built along with the access spectrum that needs to be used in the private network. So do you see that as something that can be considered?
I don't think so, because now what we are seeing is only CNPN network within a area. They want to have automation, like whatever food processing, this thing. What we are seeing is they will be able to connect through both the bands, like one you give in the capacity band and the coverage band as well, because they need a capacity bands as well. Huge amount
Correct.
of data through camera and all they have to. And coverage band, probably we recommendations are there. Let us see 3.7 to 3.8 and 4 gigahertz. What I'm talking, probably that will cover. And especially E band and V band short haul links, we may not give for CNPL, and a policy decision needs to be taken there. Now, subsequent to this 5G auction, that time itself, because we have to give a pipe also, bigger pipe. Now we are giving a lot of access spectrum, but bigger pipe is not yet decided. So decision has been taken to give E-band spectrum to them. E-band, not V-band. V-band is set to decide certain portion of E-band. And I know you are expert in the E-band radios.
Yes.
You are seeing a market there. I don't think
Yes. Got it, ma'am. Got it. Thank you so much, ma'am, for answering all of our questions. So, really great speech. I'm mindful of time. I think we are running a little bit late, but I would like to hand over to my co-chair, Dr. Ganti, to go into the next part of this session. Thank you so much, Ms. Revati.
Thank you all.
Thank you, Neha. Sonia, can you just, thank you. So now we'll have the panel, we'll start the panel discussion. I mean, the title of the panel discussion is Approaches for Spectrum Availability and Harmonization. We have 5 members in the panel. Professor Debabrati Sen, Mr. Jitendra Singh, Dr. Laura Roberti, Revati Madam, and Mr. P.B. Kumar Mohan. Revati ma'am and Laura have already been introduced. So let me introduce the other panelists, and then we will proceed further. Professor Debabrati Sen is an associate professor at IIT Kharagpur. She is a senior member of IEEE and fellow of IETE and IE. Before that, she was a postdoc researcher with Chalmers University, and prior to that, she worked in Samsung. And she is a visiting faculty with TUM Germany, and was also an academic visitor with Monash University, USA. She has a lot of publications, a lot of experience in wireless, and she has done a lot of R&D work in both optical communications and computing. She holds a lot of patents and papers. Recently, she was awarded the Qualcomm Innovation Fellowship and the Faculty Excellence Award from IIT Kharagpur in 2020. Welcome, ma'am. Sonia, next slide. Mr. Jitendra Singh is working in Qualcomm, where he's responsible for both spectrum regulation and policy. He's involved in the policy making agencies in the region. He has a vast experience in the field of communication management, and his work includes advocacy and planning and identification of additional spectrum for IMT and mobile broadband. He currently chairs a committee on IMT usage for Industry 4.0 in the ITR Working Party 5D. He plays a key role in APT telecom industry coordination activities. I mean, in short, he's one of the best known experts in spectrum harmonization and understanding spectrum management in India. I mean, I personally know him from a long time. He's one of the best. He fits into this panel extremely well. So welcome, Mr. Jitendra. The third panelist is Sri Kumar Mohan. He's an associate director in the SATCOM project office at ISRO headquarters, Bangalore. He has worked there for almost 33 years. For the past 17 years, he has been working at ISRO in the area of frequency management, involving coordination of orbit frequency resources for communication, navigation, remote sensing, and science mission. He has been contributing towards forming India's views in the WRC agenda items since WRC 12 and participates in the ITR meetings and WRC since WRC from some time. In the first 16 years, he has worked in the Space Application Center, Ahmedabad, on designing antennas for ISRO's INSAT-3 series of communication satellites. He holds a master's degree in mathematics and software systems. Welcome, sir. Welcome to this panel. So we have 5 illustrious members in this panel. So what I would suggest, the way we are going to do this is, I'm going to open the floor to all the panelists. We will have each of them give opening remarks for 3 minutes each. And once that is done, we have a set of questions that I have prepared that I'll be asking them. We'll go for 2 rounds, and if time permits, 1 more round followed by a Q&A from the audience. Okay. If any time the audience has any questions, please post it here. Either we take them at the end of the panel discussion, or we can begin at the I can intervene them in between. So I would request Mr. Jitendra Singh provide his comments.
Thank you, Jai Hind. Good afternoon. Can you hear me?
Yes, loud and clear.
Okay, thanks. So it is an honor to be part of this panel, having some esteemed speakers. And before I respond to you, I would like to congratulate Revati Madam for getting elected as a member of Radio Regulation Board. So this is a proud moment for all Indians. So congratulations, ma'am, for that. Coming to industry requirements, in my view, when we talk of industry requirements, then industry includes mobile, vertical industries, CNPN, which we spoke about, IoT, CV2X, and then many others, which Revati Madam also covered in her presentation. So it also includes, in my view, FWA, front haul, back haul, and access, because this all will actually make an entire package. Then there are demands of AR, VR, XR, explosion of immersive content, telepresence, remote digital twins, smarter factories, digital society 2.0. That is something what Japan has envisioned. And then all these will collectively need much higher capacity on all fronts. So recently, ITO Working Party 5D actually completed its report on future technology trends, which it completed in July 2022, which is a very good document to actually for us to see and go through to understand what is the technology trend which is expected, which can help us in understanding our own requirements and where we stand in that. And now, Working Party 5D is already creating IMT 2030 vision document, and it is also in final stages, which is expected to be completed by June 2023. So again, we have, I think, TSDSI actually had some inputs to this particular document, which is good, and then maybe that work can continue here till the time it gets closed. Coming to the focus on India towards spectrum availability and harmonization. There are many incumbents, and as Madam also said, that these managing legitimate concerns and usages of incumbents is a responsibility of the spectrum manager. Planning has to start now for next wave of reforms and technology adoption, especially keeping these incumbents in mind, because you need to ensure that their usage and their plans are also taken care of. So planning should be done based on social, economic, and environmental concerns, as well as to ensure the larger benefits to the society, and of course keeping in mind the country's strategic requirements, because that is most important thing. Just to say, which I have said a number of times in different forums, there is no planet B for us. So greener and sustainable technologies should be the criteria. That is how we should be looking for the towards technology. And while doing all this, we need to consider whether alternate resources are sufficient for incumbents. For example, can we move them to fiber or a different mode of transmission? Are there any possibilities of refarming of these incumbents to other non-commercial spectrum bands in a timely manner? And when I say timely, it means that we need to carry out in-house sharing and coexistence studies to be taking and that should be initiated taking into account the incumbent plans, future plans also. And once we are getting into these kind of studies, then we should also ensure that we participate in global activities on various technical studies, so that Indian requirements become overall part of the entire picture of studies which is happening. We saw this in some of the cases, especially in case of HIPS, which was under agenda item 1.4 in the recent WRC's activities. And then coming to because doing
Sure.
studies in an ad hoc manner, sorry. So, okay, doing studies in an ad hoc manner post auctions is almost a no go, and that is what actually brings in fear of uncertainty for all stakeholders. So that is something which should be avoided. We should do studies well in advance. So once again, government and spectrum manager need to ensure most efficient use of natural resource, which is the spectrum here, by prioritization of social, economic, environmental, and strategic needs of the country. Thanks. I think I tried to finish in 3 minutes.
Yeah,
Thank you.
thank you, Mr. Jitendra. Now I would like to welcome Revati ma'am to give her opening remarks.
It's another chance. Okay. Uh, so spectrum harmonization. The I don't know, the untouched subject. I will take it now.
So I would want you to speak on regulation at least in the opening remarks. A little bit on
Okay.
the regulation part of things.
Regulation, yes, spectrum regulation. Now people can say we have done a lot of reforms in the WPC, even that procedural reforms and all, like very, very simplified. You can see the last time after auctions, in the same day you got the spectrum assignment letters. And not only that, lot of regulatory clearances, permissions and all, they are on self-declaration basis now. When the 5G is about to come, like we have to do that, what is that, street furniture, you have, what is it, microcells, put on the street furniture and all. So, SACPA clearances. Even they need not take a clearance, they have to take only registration by merely paying 100 rupees in the portal. Do it. It's a sort of, yep, sort of regulatory. And when it comes to delicensing of the bands, we also try to do lot many like bands of general public interest. We have delicensed them. And when you come to this V2X for in-vehicle, that radar applications, there is already one band is delicensed, and there is a request, and we are considering other bands also in line with that. So yes, other than that, I think regulation now, the pretty fast pace we are doing it. Still, there is a scope to further improve it. Hopefully, we'll be at pace and we'll be doing it. Thank you.
Thank you, Revati ma'am. Now I'd like to invite Dr. Laura Roberti to give her opening remarks.
Thank you very much. I'll keep this very brief. I would just like to make the point that satellite and terrestrial technologies should really not be seen as competing technologies, but rather they are, in fact, complementary to each other. They need each other and they have different strengths. And I believe that this complementarity and synergy needs also be reflected from a regulatory standpoint. So from the point of view of policymaker, I believe is of the utmost importance that the approach is towards facilitating this optimal synergy between these different technologies. Thank you.
Okay, thank you, Dr. Laura. Professor Debabrati Sen, can you please give your opening remarks?
Hello, everybody. Related to this spectrum release of beyond 5G, what we feel actually that we could do a lot of experiments up to 72 gigahertz when we were doing our 5G analysis and devising the technology for 5G and measuring the campaigns. So it is the time that we should also explore above 72 gigahertz and also the sub-terahertz zone for making understanding that the very much bandwidth hungry applications and the real-time traffic applications are expected to come up. We are also going to see some kind of the XR video transmissions, and we are also going to see some of the integrated sensing and communication kind of demand coming up that requires to be supported for the next generation. So, spectrum in view of above millimeter wave is also coming up as a very important issue for the next gen. Thank you.
Thank you, Professor. Next, I'd like to invite Mr. Kumar Mohan to give you his opening views. Yes. Sir, you're muted.
Thank you, Chairman. And thank you, TSDSA, for inviting me to be part of this technical deep dive conference. And good afternoon to all the participants. As per the recently announced space reforms by the Government of India, non-government entities are going to play a vital role in building and launching satellites for both telecommunications and scientific purposes. With regard to spectrum requirements or approaches for telecommunication satellites for providing FSS or MSS, both Revati Madam and Laura has spoken in detail on the spectrum's availability and the interference issues and the way forward. Probably I would like to touch upon on the frequency spectrum requirements for the scientific purposes, and especially for ISRO. ISRO will be focusing on launching satellites for scientific missions that could be planetary missions or human space missions like Gaganyaan, and also doing research in satellite and launch vehicle design and technologies to improve our launch capacity. With regard to spectrum requirement for scientific purposes on the whole, ITU has identified various frequency bands in various frequencies in several bands starting from UHF up to 275 gigahertz that is listed in the ITU table of frequency under Earth Exploration Service, Space Research Service, and Meteorological Services, and so and so. These bands are used for meteorology, weather monitoring, forecasting, cartography, and downloading of scientific data, and the little amount of that spectrum is used also for controlling the scientific satellites that are operational. The critical ones are those frequencies that have been identified for use in the what we call it as a passive sensors, which collect the data from Earth, data or information from the Earth, from the frequencies that naturally emitted by the Earth. Another critical ones are the active sensors, which transmit the frequencies to collect the information from the Earth, and the transmit and the receive frequencies are generally the same. So any interference into these frequencies will lead to wrong interpretation or predictions of our weather monitoring or forecasting anything. So generally these frequencies are allocated, especially those frequencies allocated for passive services are not allocated to any other services, and hence we can say that they are all well protected. Whereas the frequencies identified for other scientific purposes like meteorology or space research and the inter-satellite service that also comes under science services, share with other services including terrestrial based mobile services or IMT services. So to protect these frequencies, ITU has set the conditions like PFT limits, elevation angle limit, and the exclusion zone, what Revati Madam told us, keep out distances, etc. So these conditions are stated in the ITU regulations or in its recommendations. So the exclusion zones conditions are used for those frequencies that are generally used for downloading the scientific data, that too at a few locations on the ground. So leaving those locations, the same frequency can be used for allocating or assigning for other services, terrestrial-based services, especially IMT. I think that is how even the 26 gigahertz is being auctioned or allocated by WPC recently. So in nutshell, I can say that as per the frequency allocation, spectrum is available for both the scientific and other services and need to be efficiently used following the conditions stipulated on the sharing and the coexistence methodologies. Thank you.
Thank you, sir. So, I mean, I think now that the panelists have given their initial views on broad areas of spectrum, I will just I will just ask questions to the panelists, and other people also can pitch in between. So I'll start with Devavrati ma'am, Professor Devavrati. See, spectrum utilization and harmonization very much depends on the technology that we have. Okay, for example, when we had GSM, it has different propagation, and now we are going to millimeter wave and terahertz, it's going to have different propagation. So going forward, and also with respect to 5G, the millimeter wave, and for going forward with terahertz, how do you think these technologies are going to impact spectrum allocation and harmonization? What are your views on that?
Yes, you are right that technology affects a lot on the spectrum allocation as well as the harmonization of them. But fundamental spectrum need is coming out from the kind of the services that we are dreaming for, and the kind of the demand in terms of your data rate hence are expected to come forward. Yes, in the millimeter wave, we had the huge amount of the bandwidth available, and according to that, we came up with the large antenna array structures, also the distributed array structures, advanced technologies of the MIMO. We also came up with the advanced relay architectures, and then tried to utilize this huge bandwidth of the millimeter wave. But as far as the fast level of the deployment of the network we are seeing worldwide, so we have not yet used the whole bandwidth available exhaustively. Going ahead, if we are seeing the demand that are coming up in terms of your data rate demand especially, we will see actually the integration of the terrestrial with the non-terrestrial network going ahead beyond 5G cases. Also actually giving the main thrust on the AI-enabled wireless applications, and also giving the thrust for your integrated sensing and the communication kind of the applications. Radar combined with the communications, so it is a RADCOM applications. So these are all the bandwidth hungry applications. It is not only the data rate hungry as well as the high reliability, very low latency requirement for your real traffic transmission is coming up. Millimeter wave, especially the IMT cases, outdoor communications, we have not thought of these applications during our 5G evolution. So the bandwidth, whatever is there, they will not suffice in this kind of the applications. If you wish to go ahead with the higher bandwidth requirements, you have to go for the higher frequencies. For example, 71 to 82 gigahertz, that zone we kept for our automotive radar applications and the automotive driving, your pilotless driving and all those. Slowly going above...
Let me interrupt you in a minute and say, one thing that I'm observing is, in the initial 6 gigahertz band, low frequency bands, we used to have a lower spectral efficiency, and then we made technologies so that spectral efficiency improves, like MIMO, full duplex, so many things. Currently, now the trend seems to be that, okay, the best thing is have more spectrum, and so we move to millimeter wave, then terahertz, and slowly we're approaching light. So is this a correct approach?
See, you need actually wider bandwidth for giving out data hungry applications. If you go to the sub-6 gigahertz band, you will be seeing that the portions are very much crowded, especially actually below 3 gigahertz zones. So in order to suffice all this, and if you wish to integrate the terrestrial with the non-terrestrial communication, which we never thought of actually for sub-6 gigahertz communications, if you try to integrate the AI over the wireless, so these are the basic demands that have forced us to move for the wider bandwidth and higher frequency kind of applications.
Professor Devarathi, you are saying higher bandwidth is absolutely necessary. It's the way to go forward.
Yes.
I take this view from you.
Yes.
Revati ma'am, so for millimeter, for the 5G, for 5G we have moved to millimeter wave bands, and for 6G people are talking about terahertz communication. So slowly we are increasing to light out speed, the wavelengths of light. So what about the licensing models? Well, the frequency is increasing. How are these licensing models evolving? And do you think the old licensing models make any more sense when you do access at millimeter wave or terahertz? You're muted now, please.
It's okay, I think.
Yeah.
No. It's a good question. So you talked about terahertz. The GOT with our current secretary, we are also moving at that high speed. FCC has done spectrum horizons, terahertz spectrum horizon. So a committee has been constituted in the WPC, and we did some work on it. The committee come up with the beautiful recommendations beyond 95 gigahertz. Let us open it and give it for open terahertz spectrum experimental license. No limitation on the spec, no limitation on the technology, no limitation, no interference, no protection basis. Yes, develop something and come, then we think of some licensing mechanism.
Okay.
But that band is let me complete, then I'll take the question. That band is not free as it is, because our friend Kumar Mohanji is there. He's because for the TSPs, there are people who will be fighting for it. There is for a satellite commercial use, there are people who will be protecting. But for science services, it's a silent service. So we ourselves have to protect it. Like you have Earth exploration satellite, passive, active service, space research service, and TTC operations, and all these for planetary missions. There are in this band beyond 95. Mostly allocations for these passive services and few for land mobile services. We need to protect them. And with that proposal, we have come up, committee has given some recommendations. Now you can ask, you are asking some question now.
So that's great. That's great. We're already thinking about terahertz, and we're already planning for the spectrum. That's actually absolutely fabulous to know. So what you are saying is that mostly going forward, when you go to the high frequencies, things, the licensing will be very lax and relaxed. I mean, it won't be like sub 6 gigahertz.
It should be a little relaxed. That's what even we were thinking of when we were thinking of this INT bands beyond 37 and all. Like even for auctioning, let us go for a lower unit, geographical unit, rather than a big service area, so that multiple services can. At the same time, you will see the auction prices. The prices are also very, comparably very low for the millimeter wave bands. Yes. Because you have to encourage people to use, and we'll see some change.
That's very nice to know from a research community. We are looking forward to working in this bands. Thank you. Okay, the next question is to Dr. Laura. So the question is, how do we ensure global harmonized spectrum for services while taking care of both national and regional priorities? This is going to be a big, at least I have a little bit of understanding on how the 5G harmonization have happened. So going forward to 6G and other things, I think there are lots of players, lots of national interests and priorities. So how do you think this is going to, harmonization even going to happen? Is it even going to happen or not?
Thank you very much, first of all, for your question. I think there is an innate conflict between, and the conflict is already apparent from your question, between global harmonization and the domestic priority. So perfect global harmonization, I don't want to sound pessimistic, but in my view, never. It's not possible. It's unrealistic. However, there are ways to obviate to this issue and try to optimize this balance between, again, the requirement for global harmonization and to domestic priority. Before I go there, I would just like to say very briefly that the aspect of harmonization is particularly important for the satellite community. And why? Because of the intrinsic aspects of satellite service provision. Normally, satellites have regional coverage or even global coverage. So in general, they extend beyond the boundaries of specific countries. So in order to optimize the use of the satellite resources, it's very important the spectrum is harmonized. And I would like also to add that a satellite network takes years in designing, and once it's up, is up. You cannot change the frequencies anymore. Having said that, coming back to the issue of how to best combine global harmonization with domestic priorities, well, the guiding principles are, of course, in the radio regulations, and global harmonization, I think, is relatively easy in frequency bands that are allocated, for instance, on a primary basis only to one service. I don't know, for instance, 29.5, 30 gigahertz comes to mind. Other frequency bands, like the now infamous, I would say, 28 gigahertz, is more difficult. Why? Because it's shared on a primary basis with a number of services. However, there are indications that the ITU, the radio regulation, give in addition to the frequency allocation. For instance, in terms of identifications for specific services that can be IMT, or for instance, high density satellite services. So this is another strong international indication that hopefully is taken into account when allocating frequency at domestic level. And in this I would refer to the presentation made by Mrs. Revati. I think wherever domestic priorities trump the international allocation, I believe there are still ways to try and optimize, to see that as an opportunity, to try to still allow as many services as possible. And just to make an example that may not be applicable to India, but for instance, in relation to the 28 gigahertz band, in Australia allowed deployment of fixed wireless services in a part of the 28, I believe 27.5 to 28.1. So fixed wireless terrestrial services, but only in urban centers, because realistically in those frequency bands, the coverage is limited. It's a physical fact. So they have a co-primary allocation in urban centers, but the satellite terminals are allowed everywhere else. And again, Australia is a big country with loads of remote areas, where there are some analogies, if you wish. Another example, and the last one, is, for instance, Saudi. In Saudi Arabia, they prioritize satellite use of 28 gigahertz. However, they allowed private 5G networks on a non-protection or interference basis in the band, indoor networks. And this is just an example. I'm not saying it's the best example, but these are two examples in which sharing is allowed with some domestic priorities and some conditions that still allow both services to coexist.
So essentially what you're saying is global harmonization is going to be difficult because there's lots of competing interests across the various regions. Okay, I'll come back to this question in a little while. So Mr. Kumar, this question is for you. So what do you think, what are the frequency bands that ISRO would require in the next coming 1 decade? What are your projections for that? Sir, you're muted, sir.
Sorry, thank you for the question. As I told earlier, under the new space reforms, there are several non-governmental entities that are going to come in this field, and they will be providing both telecommunications as well as rather building and launching satellites for both telecommunication and scientific purposes. So both of us, both the satellites would be requiring a lot of bandwidth. I feel that now the trend or the requirement is to meet the new generation or next generation services as listed by Revati Madam. That would require bands from Ka to Q, V, and W bands. Of course, the systems are evolving now only. Of course, Ka band, there are several satellites already providing services for even for a broadband at home. Of course, we are ready to launch that fully Ka satellite. But from ISRO perspective, we also will be needing Ka, Q, B, and W bands. Of course, we have to start with the Ka band. For remote sensing or scientific satellites, of course, bandwidths are available. As both earlier speakers told, the only challenge is how to coexist with the terrestrial and especially IMT services. And there is no other way but to coexist and to find a way to coexist. Thank you.
Thank you, sir. Jitendra, the next question is for you. Is there any? So essentially, I want to ask. Currently, is there any work that's being planned or is in progress in both in the about 5G plus and 6G in the global bodies dealing with spectrum? I mean, can you give us a short answer?
Yeah, thanks. Good question. And then actually, your earlier questions were also good, and had an itch to respond to some of those, but of course, that is already responded. Coming to this particular question, yeah, there's a large amount of work which is already going on 5G Advanced and 6G, both in by industry and by academia, and also in various global bodies where they all come together and their work is already on. There is already an agreed timeline for IMT 2030. uh, so as I informed earlier, that the IMT Vision document is getting finalized shortly in June 2023, and then post that the work of creating IMT 2030 technology, or that is 6G, in terms of commercial terms, will be done by 2030. That is what is expected, and one of the important activities which is part of this entire journey when you create a technology is creation of technical performance requirements. And I remember you personally, Dr. Radha, pushed LMLC as part of this TPR in the previous cycle of when we were working on IMD 2020. So that is something which is important activity. As a country, we should be now focusing on what are our requirements as we go forward, especially keeping in mind the future technology trend activity which has happened in 5D, and how can we bring those inputs into the work which will start happening from 2024 onwards. And so that is important. And already a close collaboration between ITUR and 3GPP is already on this particular thing. Typically, it takes about a decade to develop and deploy a technology. So for Indian entities to participate in this, is important to start working on these studies. As I said, that we should start looking at our requirements. That is important. And spectrum will be required in all the frequency bands: lower range, mid range, high range. It is not that only one particular range can suffice. We saw this in 5G, and it will be more of the case as we move forward. So for so-called 6G, we cannot say that this spectrum uh, is okay for the technology, but we cannot give it because it is we cannot share it because we are using it for something else. So at least we should get support studies. We should participate in those studies, and we should see whether coexistence is possible or not. And as what Revati madam presented earlier, that whether we can work with some guard band, whether they can coexist, whether we can use some technology like cognitive radio kind of solutions, or I don't know, whatever is possible in future, we can work on those. And right now, when we are focusing in this entire global work, there are two frequency ranges which are right now discussed. One is 7.125 to 24 gigahertz, and other is 92 to 275 gigahertz ranges. And I believe DOT recently, I think maybe yesterday, if not, I'm not wrong, in has is I think is trying to approach TRI to see whether band 92 to 300 gigahertz can be used for trials of 6G in India or not. So that is something which is already, as Revati madam said, that Honorable Telecom Secretary is already very super fast in this, is more than 6G in this, and he's already pushing things fast. So yes, we need to have a spectrum identified, especially if not global identification or global harmonization, then we should be focused at least for region at a regional level at least. So this is my
So,
short response.
so from India, we should be ready in the next couple of years. At least locally, we should have an understanding of what spectrum we require, and uh,
Y-
this kind of
y-
stuff is something that we should be ready from India. At
Yes.
least in
So
the next
actually,
couple.
yeah. So just to respond to this part, yes, it is important because the process is understanding process is very important, and process wise, next year, which is 2023, we will have agenda item coming up in WRC 23 for WRC 27, whether we have any spectrum identified for next generation of IMT or not. So we need to push it there. We need to push it in Asia Pacific level in APG meetings. Unfortunately, we did not have any spectrum in the previous cycle for region 3, only 100 megahertz. for the entire region, which is 7025 to 7125 megahertz. So that was not is probably not sufficient. So we need to focus on this 7 gigahertz, which is a mid band, and probably also in 90 gigahertz and above.
I think a lot more coordination is required across various agencies in India. That's what it looks like. Okay, so we'll go to the round 2 of questions. So this question is for Mr. Kumar. See, in the recent 5G allocations, as Revati Madam also pointed out, there was, IMT allocations have happened, and after the IMT allocations have happened, both in India and in US and other parts of the world, there has been a lot of hue and cry saying that these bands are interfering with each other. Okay, there has been almost a 1 decade of preparation for identifying these IMT bands, and studies have happened, ITU, 3GPP, so many. But even after all this, in specifically in US, the whole 5G deployment for some regions has to be put on hold because it was interfering with the aviation industry. Okay, rather it's the other way around. Aviation industry filters were not good. So how do we prevent this going forward? I mean, it's going to become more complex. It's not going to be easier. Okay, and on a relevant note, does this imply that ITU harmonization is not working? So you're muted, sir, please.
Sorry, every time I forget to
No,
Thank you very much. Yeah, I think Revati Madam also touched upon this issue, especially in the C-band. C-band is critical even both for satellite industry and the aviation industry. Aviation industry, I'm not much aware of that, but I know the interferences there. But everywhere the issue is, as Madam explained, there are legacy systems where the filter was not designed to filter only those bands that can be allowed inside. But in addition to that, if you see that the band 34, as far as satellite is concerned, I can tell confidently that the band 3400 to 4200 was majority satellite operators were using for the TV broadcasting, as well as and the few of the satellite operators used for as a feeder link for disaster management services that are provided in the lower frequency bands. And moreover, as you know, this C-band has a lower, less rain attenuation. So it becomes very ideal for the countries that are lying between the Tropic of Cancer or tropical regions. That is why people were not, the satellite operators were very reluctant to allow IMT or any other services. In fact, this has been going on since, if my memory is correct, 2007. In 2007 itself, this band was discussed, and ITU sharing studies told that coexistence is not possible. That is why IMT was not allowed to be deployed in this frequency band, at least so far. But now the countries have decided, and seeing the potential for terrestrial services, they started, slightly releasing few of the bands, and especially what we call it as a lower extended C-band, that is 3400 to 3700. In fact, ISRO also had a couple of satellite, INSAT-2E earlier and GSAT-10 second satellite. But in fact, we in India, ISRO along with the WPC did experiments around 2008 or 9 time. At the time, WPC was intending to use this band for broadband wireless access. The experiments we conducted in Chennai, and it was found that the quality of the video received by the cable operators were very, very poor. So it was given up at the time. But of course, it was not used by further used by satellite services also later on in India. But of course, the other satellite operators, especially the Indonesia and the Southeast Asian countries, continue to use this band 3400 to 3700 for this purpose, and other VSATs communications also. With regard to 26 gigahertz, I think there were two issues. One is this band, another one is the 26 gigahertz. In 26 gigahertz also, ITU studied and found a exclusion zone, what we call it as a keyport distance. And we did analysis in ISRO at the locations. We have one ground station at Hyderabad in National Remote Sensing Agency Center. There we received the satellite data downloaded by our Cartosat satellite, which is using the 1.5 gigahertz in the 25 to 27.5, which is allocated for IMT also. So what we did is, based on our analysis and DOT also agreed to protect those stations. In addition to a few more stations where we plan to, install ground stations to receive the data. 5 to 7 locations have been given protection with the radius of around 2.7 or 3 kilometers, something like that, depending upon our reception requirement. So this is how we coexist in India. Even in other countries also, they follow the same principle. They identify the locations for such reception, because it is not like telecommunication services where your ground receivers are going to be ubiquitous. It is going to be only a few stations. Only the interested organization or agencies are going to use, and the data downloaded will be used by several agencies which may not need direct reception by the satellite. So this is how coexistence is possible, and that is how both systems are working. And in particular, I want to tell, which Revathi madam also highlighted, that is our IRNSS CDMA ranging, where we use 25 megahertz of band in 34002 to 3425, where we use both the geostationary satellite as well as non-geostationary satellite in order to provide the precise position, navigation, and timing parameters. So there also we did interference analysis, taking the inputs from the IMT proponents, and identify the exclusion zones. Not only the circle, even we identify the in terms of azimuth angle where we will have a severe interference. Those zones have been identified, and the rest of the zones have been allowed to be auctioned for IMT in this frequency bands. So I should say that it has become the day after exigencies that you have to coexist. It may not be possible to coexist both at the same geographical location. We have to find a way out, and how to efficiently and optimally use that, we have to identify and go forward.
One thing I would like to add here is, I think it is important that these agencies also participate in 3GPP when this bands are being discussed, because that's also very critical. Because N78 band has been identified in 3GPP from a long time, while the studies are happening here. That's just a point for consideration, sir. Okay. Thank you, sir. The next question is for Revathi madam. So what is the current spectrum situation in India compared to other major economies for 5G and the next generation? So how do we measure the effective use of spectrum? Okay, if I say I want a number saying that for 6 gigahertz, this is how well the spectrum is used. Can you give a simple number like for India, saying that out of range from 1 to 10, the use of spectrum, we are at 5 or 8 or 10?
I think a wrong question to a wrong person. From the spectrum manager side, because they are buying from the market, we think they are efficiently utilizing it. They always say that, and we are giving at a very high price.
Yes.
So industry normally say, but generally we do for auditing. We recently taken a performance audit. Performance audit for especially government agencies we did. Because they are holding a lot of commercial IMT band for other purposes, whereas IMT people are asking for more spectrum. We really want to see whether they need that much spectrum or efficiently utilizing, or we want to take it back to put it to better use. There we did, and we as you are aware, I think everyone is aware, governments are not that efficiently utilizing that spectrum. Come to the industry, truly I may not be able to answer. And now the benchmark is, once we are at auctioned prices and all, we presume they are using efficiently, and we have put sufficient caps there so that they cannot hold the spectrum. We have different caps for different frequency bands, and merger and acquisition, we have put set guidelines so that they cannot hold the spectrum. Then come to, you are asking one more question, compared to international standards.
Yeah.
Where are we?
Yeah.
See, I think now we were comfortable. We are almost at par. When you start seeing this millimeter wave band and this mid bands, more or less we are compared. And when we come to higher bands, we have analyzed, like FCC, Ofcom, and Japan, how did they? And some of the people, they are going ahead, they have already auctioned certain portion of. They went in the direction of band segmentation to start with. FCC and all, when they went in the 37 gigahertz band, certain portion of the band they try to auction for IMT, either starting portion of the end portion, something like that. Some of the Japan and I think Australia, they are observing the market for the deployment of the ecosystem and that. Now I see we are at par with the countries. That's my view.
Okay, ma'am. Okay, ma'am.
Thank
So you are saying that okay, at least the auction spectrum people are utilizing very well, but the
Yeah,
unauction,
that's it.
a lot more audit has to be done. Okay,
Yeah, we have been doing it. We are
you have
doing.
been
We have.
doing it, and you have to have
Yeah, GOT itself has initiated that. Ask the CAG, please go and do the auditing of all the department, the government spectrum, whoever is sitting on the commercial spectrum.
Oh, thanks, ma'am.
And we got the report as well.
So the next follow-up question is for Jitendra. See, I mean, most of the next generation technologies are focusing on high bands, mainly for a reason of spectrum. But actually, if you look at it, the good spectrum is below 6 gigahertz. Above 6 gigahertz, the propagation, so many issues are coming up, propagation issues and everything. So my question is, can we do anything about the spectrum below 6 gigahertz? Should we take a closer look at it, reform it completely, and say we reallocate everything? I know this is a controversial statement, but should we do that? Because at least my understanding, deployments in millimeter wave and other things are not taken off so well because of propagation issues.
Uh, Good question, and as you said, it is controversial also. So, but before we actually take that step, I think we should see that what is the actual requirement. One is sub gigahertz. We have good amount of spectrum in sub gigahertz, and I believe some discussion on 600 megahertz is already on in band plan which India has adopted, and I am sure that TSDSI is going to support that activity in 3GPP right now. Other is mid band. Mid band, just limiting it to below 6 gigahertz is, I think, is will be kind of some limiting factor, necessary limiting factor we would like to put there, which is not the right approach in my view. We should look up to at least 15 gigahertz to consider that as a mid-band range, because those will have almost similar characteristics in terms of propagation. Anything above 3 gigahertz would have that kind of characteristic, propagation characteristic. In India, the mid-band situation is not really good because we only have 3.5 gigahertz band, which is 370 megahertz of spectrum, which was auctioned. And of course, we have certain portion, as Kumar Monji explained, for IRNSS CDMA ranging receive systems. So that is where we have limitations of usage of spectrum, very as a neat and clean spectrum for IMT deployments. We have some limitations. We have limitations coming from other government users, which we cannot discuss in this fora. Then we have limitations coming because of TVRO systems. So we don't have entire band available. Then other band which is also available in mid band range is 4.9 gigahertz band. Again, we have government agencies using that band, and probably only a small chunk of that band, which is around 50 megahertz, which may be made available possibly at the most. So we don't have enough spectrum available in mid band. Therefore, I say that don't limit ourselves to sub gigahertz, expand it to maybe uh, going up to say 15 gigahertz. An important thing, if you see, which I actually explained earlier also, that in agenda item 1.2 of current WRC cycle or WRC 23, there's only 100 megahertz band, which is 7025 to 7125 megahertz, which has been discussed or considered for region 3 for IMT. So we are not having any band in between entire 6 gigahertz. So it means we need to actually look for more spectrum for doing mid band requirements. And typically, I would say that if we want to go, we should go with 7.125 to 15 gigahertz. Try to see what are current users, what are their plans, how we can do cohesion studies. Can we have larger bandwidth available for these kind of requirement? Can we go for regional harmonization? Can we have global harmonization in certain cases to achieve economies of scale? So I think studies should be done, and India should be leading in some of these work on studies. We should not block studies. Band segmentation and all can be done within the country, but studies can be for the entire band, and we should be supporting entire band discussion. And then later on, once we know that what are the parameters, like we know about 26 gigahertz band, we know about C band, So that band segmentation can be done separately within the country. That is the administration's prerogative, and then maybe spectrum manager can handle that part depending on the incumbent plans. So my view is that overall planning should be done based on the overall need of the country, social, economic, environmental concerns. And these are the things which are giving larger benefits to the society. That should be the criteria, and we should go ahead with the studies for the entire range. Where it is not possible, like example 31 gigahertz, which we did last cycle, WRC cycle, it was not possible. It was decided that it cannot go through, so we did not touch it. But other places, so I think that is how it should be treated, sub 6 gigahertz. And so we cannot limit it to sub 6 gigahertz. Maybe we should call it mid band range.
So
Thank you.
your answer is it's too messy below 6 gigahertz. Don't touch it. Let's expand it to 15 gigahertz and make
Yes.
sure that at least from 6 to 15, it's all cleaned up from the beginning.
Yeah, studies are, at least studies are done, and then we support those studies. And that is what.
Absolutely. Good. Thanks. Thank you. The next question is for Dr. Laura. So this is about the convergence of terrestrial networks and satellite networks. So, I mean, in both 3GPP and ITU, there's a lot of talk happening about satellites being used for terrestrial coverage and other things. So from a spectrum perspective, how do you compare the spectrum utilization of a satellite for terrestrial coverage versus an IMP operator? And what do you think is the impact of this on the spectrum allocation?
Thank you very much for your question. This actually allows me to link with what were actually my introductory remarks, that is this complementarity of the two different technologies and services, the satellite and the terrestrial one. So I would like to expand a little bit on this specific issue. Again, it is clear that no single technology can satisfy all telecommunication needs. So it can be only terrestrial, only satellite, only GSO, only non-GSO. They all have different strengths. When it comes to satellite and terrestrial, I see two types of complementarity. One is geographical, in the sense that satellites, because of their nature, can provide services where terrestrial can't, which means in the water, on the oceans, up in the air, or simply in remote or rural areas. But the complementarity can also be seen from a different perspective, in terms of complementarity in different parts of the links. And I'm referring, for instance, to the possibility, especially for novel high capacity satellites, to provide, for instance, backhauling for terrestrial services that will be very much in need, especially as we move towards 5G and now possibly 6G. That implies a huge amount of data. And novel satellite systems, again, will be in an ideal position, one, for the unprecedented amount of capacity they are capable of delivering, and then because of the satellite technology as such, when it comes to backhauling. So they can really be complementary to the terrestrial services in decreasing, and they have several advantages, decreasing the time to market, for instance, lowering the risk of investment for the terrestrial for the terrestrial providers, allowing also for revenue generation in hard to reach places, and also limit or eliminate the deployment of terrestrial infrastructure that can be fiber or microwave towers, for instance. So all this to say that, again, in terms of impact of spectrum, there is no need as such to limit the number of, for instance, for backhauling. It doesn't make sense to limit the number of satellite operators, because they can all be available. And then this allows simply more choice for the user. And it's the same case, for instance, for in-flight connectivity and so on. At the same time, in order for satellite to provide these complementary services, they need to have access to spectrum. And when it comes to novel satellite services, I would say that the vast majority of them, either for user terminal or for gateways, they use Ka-band. And hence, it's a self-explanatory situation in that respect.
Thank you. So essentially what you're saying is both are complementary. You should not think of them as competing systems. We should figure out a way to make sure both of them coexist and utilize each other in an effective manner. I think
Absolutely.
I like that point.
Thank you.
Okay. Thank you. The last question is for Professor Debarathy. See, in all the spectrum studies and further in 3GPP simulations and other things, channel modeling is a very critical thing. Okay, so if you look at coexistence studies, channel models play a critical role. It turns out that at least in ITU, whatever models ITU use are all one size fits all model. Okay, so this is specifically untrue for higher frequency where humidity plays a role, geographical location plays a role, so many things. So what do you think we should do in perspective? Should we make our own channel models and then should we do these studies? Because it's critical. If you want to understand coexistence of spectrum, we require these channel models, but we just borrow it from ITU.
Very good question. Very good question and very relevant too. Because whenever we try to come up with a new technology, you need to understand the behavior of the channel. It's a channel modeling, either through the experiment or through the mathematical model. You have to understand the propagation characteristics before you try to understand whether we can support such kind of the requirements that we are searching for this kind of the bandwidth requirement, this kind of the transmission frequency requirements, this is the density improvement, and what are the limitations are going to happen. So another side is that once you go for the practical experiment based data collection and fitting it to a statistical model, it consumes huge time. It involves a huge funding. And also for above high millimeter wave range, terahertz, even in your mid communication zone that we are now talking about, the instruments are going to be very costly. And doing the experiments exhaustively for all kind of the geographical location sometimes is not going to be feasible. Let us take a very simple example that even if can we do the experimental study for behaving or understanding the channel for suppose a regular speed of 350 kilometer per hour and above in the range of 15 gigahertz band? The answer will be a very big no, because where are the transmit, receive, and how will you capture such data, and what are the reliability of such data so that you can fix it over the typical channel condition, understanding the behavior of the channels, and then you come up with the proper modulation coding schemes and the receiver transceiver designs. So channel model always will be a inheritable part going ahead with the parallelly with the experiments, channel measurement experiments done in practice. So the country like India, where this research funding and getting actually this a very high actually costly instruments and exhaustively doing actually for such kind of the experimental trials for different kind of the geographical locations, the different geographical locations that we are having, the variety of the geographical locations that we are having. I strongly believe that we should go ahead with a kind of channel model for the next generation, and then also parallelly go ahead with validating that model with the kind of experimental data we are getting. It is not about the getting experimental data in an environment which is running in Japan or in Korea or in USA, because their geographical location as well as the weather condition largely varies than ours. So we should have our own campaign parallelly running, maybe at a smaller level, but at different locations with the proper funding. We need actually the huge support from government in this regard, as well as from the industry houses, to develop our own ecosystem to support our channel models. Channel model can go fast.
So yeah, that's kind of what I also believe that I mean we required to do our channel studies and contribute this back to ITU. I don't think going forward this one size fits all is a good paradigm. I mean they should have parameterization across based on geographical areas. This is important. I think that's a point well taken. So I think we are running out of time. I would I don't know. I mean. Neha, do we have time for just one quick question from someone from audience, or we should wrap it up?
Yeah, sure. We can take one question.
So Sonia, can you just put the last question from Mr. Arun? I think this is for Jitendra, if I'm not mistaken.
Yes, and a good question. Can I go ahead with the response?
Please go ahead.
Yeah. So actually, if you see the propagation models and then the parameters of moisture and rain and water. 18 to 19 gigahertz is the spectrum band which is actually having water vapor absorption peak, and that is one of the reasons that if you see the radio regulations, you will find that 18.6 to 18.8 gigahertz is the band where we have EESS passive system to study this kind of phenomena. So I think that's why I limited my point towards from 7 to 15 gigahertz without getting into 18 gigahertz part where actual peaks and we have this issue, possible issue of having the different characteristics of propagation. So maybe we can still go ahead, and that is the reason that if we see radio regulations once again, we'll find that mobile is one of the key co-primary service in up to 15 gigahertz at least. So I think that is one of the reasons I actually suggested to go with up to 15 gigahertz. Hope I think I have answered this.
Yeah, I think that's a perfect answer, brother. Sonia, can you put up the next question by Mr. Balaji? We'll just take this one question and we can stop. I think this is for Revati madam. I don't know if she's still there. Yeah. Revati ma'am, you're muted, ma'am. Hello. Revati ma'am, you're muted. Sonia, can you unmute Revati ma'am?
No, sir. Ma'am, can you unmute yourself only? Just click on the middle bottom. There is a mic button. I hope her network is not showing good. Maybe the issue.
I think I I think it's not audible. I think we'll take this question later, ma'am. I mean, maybe you can respond it later. We can get the audience and. Okay. So I first like to thank all the panelists. It has been a wonderful time. I mean, listening to your answers and responses. I mean, I had a great time and I learned a lot. I hope the other audience also did the same. So, in sum, I just want to summarize what we have learned. That things are going to get complex going ahead. It's not going to get any easier. There are lots of technologies that are competing for the spectrum, both terrestrial and terrestrial satellite, and in terrestrial IMT. I mean, across different bands, Wi-Fi, cognitive networks. So the spectrum planning is going to get more and more complex. The only solution to this is you have to start early, sit down, chalk out the differences, and then go as a common voice to the global forums. This is absolutely necessary. I don't think we should see each other as competitors. I mean, that's not going to solve any problem. I mean, we have to figure out what are the needs and requirements of the country, and based on that, we should project our spectrum needs. It's going to be an exciting decade. Until now, people have been talking only up to sub 6 gigahertz or 10 gigahertz, but now people are talking about higher and higher frequencies. I think it's going to be an interesting decade of looking at spectrum issues in this kind of bands. With these words, I would again like to thank all the panelists for being here patiently and listening to me and answering all the questions. Thank you, sir. Thanks, everyone. Neha,
Yeah.
the floor is yours. Thank you.
Thank you. Thank you so much, Dr. Ganti, for this very engaging panel discussion. I think a lot of nuts and bolts of the problems were discussed, very effectively by you and your panel. I think spectrum planning discussion is something that brings together industry, academia, and government. And all of these different, players have been represented in this session. The coexistence of satellite and terrestrial network is something which is always a discussion and which is something which is always work under progress. But I think real action has been taken on certain frequency band, setting the ground, as highlighted by Dr. Kumar Mohan. I think those are the things that needs to happen more and more. There is a clear need for policy for usage of spectrum by NGSO in the presence of GSO and terrestrial networks. I think this is also something that was highlighted by Laura, our keynote speaker. And here I would also like to note that more and more participation from Indian entities into forming global regulation is happening lately. This is also motivated by the technical leadership, that India wants to establish in the next decade through its innovation and strong industry ecosystem. There was also a call for India-specific interference studies, to plan the spectrum better by Ms. Revati. I think, unlike the previous decade, we are now in an environment where the usage of spectrum is more and more dense. This requires all the systems to adhere to the channel bandwidth that is allocated to them, and design their receivers accordingly. And we have legacy systems which are not following this, but I think the good news is that the Indian government is also supporting replacement of these legacy systems financially, as highlighted by Ms. Revati. A right balance between adopting global regulations for reaching economies of scale and also coming up with India specific regulation that fit our particular environment is required. At the end, I would really like to note that this session also saw equal representation by women. In fact, both of our keynote speakers were women, so 3 cheers for that. With this note, I would like to thank all the speakers and especially the organizers for all the hard work that has gone into making this session a success. And I'm happy to say that we are ending the session right on time, 4:15. So thank you so much for everyone to cooperate in terms of time. So thank you so much. I hand back the mic to the organizers. Thank you.
Thank you very much.
Thank you, everyone.
Okay.
Thank
Thank
you.
you, everyone. Thank you.
Bye.
Thank you.
Yes,
Bye-bye.
Thank you,
now,
I
I'm
just
ending
leave.
the session now.
Yes.
Thanks a lot.